Okay, I think we're just ready to start. Everyone up there? Hi, everyone. Cool, good to have you. So this is, we got this on the screen? Good, okay. This is an informal talk. And the reason is because the main reason I came to Oslo this time was NDC once again, but this was us last night at the Oslo Spectrum. Yeah, it was a great event. This is the picture I've been sending to my family and friends of us on stage. Okay, let me just change something here. I want to put this on duplicate, I think. Nope, that's not what I want. Let's see. Let's try this. What's happening here? Why aren't we on? Sorry, excuse me. What's on here? Try that again. All right. Okay, we'll leave it like this. We'll get going. Okay, so it's an informal talk. Despite the fact it's about user interfaces, it's not full of flashy demos. At least it's not full of my flashy demos, because I'm a programming language designer and not a user interface designer. And so, but I do have a little video of some flashier UIs that are being done with the fabulous framework. But I'm going to really talk about, you know, when you build a framework, you need the framework, and then you need a whole lot of people who are actually really good at using it. And I'm the one who's kind of building it. We started it off, and now there's a whole lot of contributors coming along. And actually, this is very much a community-driven, community-owned user perspective on functional user interface programming. And it is one of the most enjoyable things I've ever got to work on, and that includes F#, it includes .NET, it includes async, and lots of other things. But this is something really gave me a lot of pleasure to start off this project, and I would love to get you involved. Come and not only involved, but yeah, really helping drive the direction of where this goes, and complete it out in certain directions, and build out the tooling story, and also to use it and have a fabulous fun time. So just to give you a feel for some of the community who's involved, we have Jim Bennett. Many of you know, he's one of the great evangelists in the .NET space and in the Xamarin space as well, mobile programming. Now, this talk actually steals several slides and the video I mentioned from Mark Malabone, who's a MVP in Switzerland, and you know, he's a great contributor. It also takes inspiration from the work of Frank Kruger and several other projects that have come before that have started down this direction. And I feel that, you know, things have really come together and crystallized in fabulous. Okay, so what's the kind of context where I started this work? It is that when we brought F# to .NET, the mantra was always, we're going to bring functional programming to .NET, and we're going to bring .NET to the functional programming world, and we're going to get the best of both worlds. And that's kind of the driving spirit behind what F# has done, and so much of what you see in there, you know, what makes up .NET today. Generics was a part of that story as well, and so many of the features that are in C# and the ways of thinking, compared to the world as it was back in, you know, 20 years ago, where everybody was doing inheritance, implementation inheritance for absolutely everything, hierarchical classification for everything. You know, they did null pointers back then, and C#'s just trying to get rid of those now, struggling hard on that. But yeah, we've come so far in integrating these worlds of practical programming with .NET and functional programming, and proving that functional first programming is an immensely practical paradigm. But we made mistakes. Okay, and one of the mistakes I made, or one of the holes in my knowledge, was I had no particular point of view on functional first app development, application development. We always just said, okay, F# for the back end, for the logic, of your program, and you do your user interface in C Sharp or Visual Basic or whatever, or JavaScript front end. And that's kind of, there are reasons we did that. One is that the front end had this incredibly heavy tooling. It didn't matter which generation of front end programming you're talking about, whether it's Windows Forms or UWP or WPF or Xamarin or whatever. It just seemed like this cornucopia of complex tooling that was actually quite technically difficult to make work with the new programming language. And so that was one pragmatic reason, but also we didn't actually have a strong point of view on what functional first app development really even meant. And it wasn't until a language called Elm came along that showed that functional programming is immensely relevant to web application development that I realized actually functional has a huge role in the user interface as well. And the Elm inspired a paradigm or framework called Elmish, which many of you will have heard of, which is used for web programming with F#. And so that uses a compiler called Fable. So Fable solves the user interface. Fable and Elmish solve the functional first development for web development, and both client and server side. But F# devs also need to be able to go mobile. They also need to do UWP apps. Some old-fashioned ones might do, GTK apps. They also need to be able to do WinForms apps. They need to be able to do WPF. Okay, and we need to think about app development. So Xamarin is a very sensible place to start with this, because Xamarin Forms is an amazing cross-platform, cross-framework sort of unifying story for app development. And so we wanted to really, from the F# perspective, can we make Xamarin a simple and compelling for F# app development? Okay, and it's good. Things have changed since we started F# way back, and we have now this paradigm MVVM, and there are lots of MVVM frameworks in the world. There are very old ones like GTK. There are Xamarin wrappings around the Apple ones. There's WPF is a huge one. We have Xamarin Android, we have UWP, we have Xamarin Forms itself is an MVVM sort of framework. And you'll notice there are lots of old-fashioned icons over on the left. And they're old-fashioned because partly there's a new generation of frameworks taking a very different and interesting approach compared to MVVM, and we call these MVU, Model-View-Update. And these ones over on the right have these nice, modern, flowing icons, and there's a reason for this. We have Redux, we have Flux, we have React Native, and we have React, and we have Flutter, and we have Fable and Elm here. And over on the left, what characterize these? OO programming, absolutely. You have these generally complex, mutable models and view models, propagating changes through signals up to a UI, which is usually implemented in a second language, is declarative, and because it's in a second language, it's kind of static. Not completely static. It's got bits of knobs and dials, and you can turn things on and off, and but anything that any possible UI state or element has to be lifted out of the app and kind of sliced off into this static UI, and it often and there's this big trade-off. The reason they do that is because they want designer tooling. But the designer tooling gets very complex because you've kind of sliced off the user interface out of your code. Over on the right, these are characterized by much more functional thinking, much more not always completely immutable, but much more immutability sort of thinking, or the view is a function from an underlying declarative model. And interestingly, the UI tends to be much more declaratively dynamic. I'll be talking about why later. And the view tends to be in the same language as the DSL, not always. Some integrate some markup. And the tooling they use tends to rely on live coding tooling, which is relatively simple. Has its glitches, certainly, sometimes, but it's relatively simple compared to the kind of complex designer tooling. Fabulous, for instance, which I'm talking about today, the live coding tooling is just completely in the repository. So if you want to help work on that and improve it, you're not relying on a whole stack of tooling provided by Visual Studio or other Xcode or other tooling environments. Okay, so things are changing, and let's take a look at these two different settings. I've described these a little bit. We have view model, and we have this sort of data binding between the view and the view model, and then the signals going back between the view model and the model. And these things are mutable, and the view is mutable, and then over on the right we have MVU. So you can do MVVM in F#, and you can do it over Xamarin if you like, and this is the sort of thing that you get. Can you see my pointer? No, this is the problem. I don't know what I have to duplicate. This is what I think I want. There we go. Yeah, okay. Right, so this is what it looks like, and as you can see, you're building a view model, and straight away you've got, oh my God, you've got mutation, and it's okay. It looks actually quite nice. It's quite okay in F# to do if you have to do mutable OO programming. It's a totally fine paradigm to use for many types of programming. But still, the mutation is coming in very early and very intrinsically in the whole architecture of your application. And you get this sort of thing to kind of implement triggers and property changed event args and create commands and so on. It's quite this MVVM world is not only complex in its kind of fundamentals of having this mutation around, but it's quite conceptually complex as well. You've got a lot of terminology to learn, like because the user interface language has all these widgets like these things, commands and property changed events, and the underlying programming language doesn't have those, and you kind of got to make those meta and actually create objects for commands and so on. And yeah, okay. So in contrast, this is how model view update works. You have an underlying model, you have a view, you have a message, and the message comes back and the model gets incrementally updated, and then the view gets re-rendered. Okay. And this confused me like crazy for a long time. I was just like, how the heck does this kind of add up to so they're actually re-evaluating the view on changes to the underlying model. And you just suddenly, all these warning signs go off in your head. Isn't that going to flicker? Isn't that going to be too costly? Isn't that, it's just not, can't anything flow back? But then through the performance considerations are real. You have to incrementalize things. And there's a whole set of techniques you can use to incrementalize this, but the fundamental information flow stays the same. And it's incredibly simplifying to that there's only one direction where information goes in your whole application. It's just round and round and round. And you can individually unit test each of these parts, and each of these parts are just functional programming. They're just functions. The view is a function from the model to the view. The messages are just functional programming data, discriminated unions in F# nearly always, and the update of the model is just a function to update one model to give you a new model. You can unit test those. Because it's information flow, there's very few places for things to go wrong, in a sense. I mean, you can still make mistakes, of course, but the magic of functional programming, strongly typed functional programming, really begins to work here. And this is why Elm works so well, it's why Elmish works so well, and it's why Fabulous works well. Okay, so I've covered some of this. Just to say a big shout out to the people who are working on Safestack. Some of them are here. It has really proven to me. Now, Safestack is a server-side and client-side with Fable, Elmish, but on the client side. And it really shows that non-F# people have been able to pick up this kind of programming, do the user interface side of it in business contexts, You can talk to Stefan Forkman about this. They find it really, this is a really simple end of F# programming, okay? This is not, you very rarely have to define a type, and if it is, it's just like a record or something. You very, very rarely have to do anything difficult. It's just absolutely simple F# coding. Okay, so let me rant a little bit about Zamel. I can just kind of let loose here. So I've hinted at some of this already, some of this way of thinking. Zamel assumes designers are sliced off the UI from the code, and therefore Zamel ends up with static. It's got these layers of complexity. Because it's not a programming language, they have to start adding in all these programming language features, like templating, okay? They add in all these things that smell a lot like code to me, right? The behaviours and converters, and they have all this complex design tooling, and it does fail, this tooling, let's be honest, yeah? And separating the UI itself is fine. In this model, the UI, the model to the view function is actually fully separated. You can carve it off if you want and put it in a separate component or whatever, unit test it separately. But do we really need a fully separate language to do this? Okay. So this is so Zamel ends up baroque, layers of complexity, and to be honest, I will say something quite strong, which I feel Zamel is a bit of a complexity disaster. Now that's a stronger position than any official Microsoft position. Like Zamel is actually used effectively by both F# and C# programmers. Many applications are written in it, but in some sense it feels like a bit of a category mistake. In this dynamic UI should be separated into a static markup language. That just doesn't compute to me at some level. I mean, anyway, this gives you an alternative perspective on how that, if you're going to do that slicing, maybe you don't have to slice it in exactly the same places. Okay, so let's take one example. You want to do how to not a binding in Zamel. Okay, so you've got is enabled here, and it's late at night, and you're trying in 2015 on the Xamarin Forms forums, and George Cook here, thank you George, is trying to know this bit is what I don't know how to do a not in the user interface. Not because the view model, which you can't change perhaps, has got is logging in, and you want is not logging in, right? And what you need is one of these converter things, you know, this is great. You know, you got a negate Boolean converter with an inverter. Well, thank you, Joe, for answering the question. And button clicked, on clicked, image, this, etc. And then you actually have some C# code to return not here. And you can actually download a NuGet package for the negate Boolean converter, and I think, or a collection of converters that are commonly used, and then of course your app might get quite a bit bigger because there's all these converters you didn't need in there, and on you go. But of course it didn't work because, good answer, but someone who's not much familiar with Zamel, they need to add the namespace in the Zamel file to use that converter. That's good, okay, right. Fine. So just to say, how does this look when your view is a function from the model, and which is allowed to dispatch messages? This is a function, view, and it takes a parameter model, and it takes a parameter which is a dispatch function, allows it to dispatch things. And you can see the full view here. It's a content page, stack layout and everything. And down the bottom, we've got a can you execute the reset button, and it's if the model has changed. But what if the view model said unchanged, okay? Well, in the function, you would just do that. Okay, there, let's look at that again. It's hard to find that on a forum answer question because it's so easy, okay? Because you've got to reevaluate the view on each model update. Then you just reevaluate this, and you differentially apply the updates on from the shadow view through to the actual controls, and the element will change from can execute to not execute. So you're going from a world where you need this sort of thing to a world where you just code and just put in the not. So how easy is that? Okay, so that's the inspiration. So what's needed? The simplicity of Fable and Elmish, but for apps. And this is, I'm just running you through some of the getting started things. So let's take you through where we're actually at here. So we'll go to the fabulous website, which is here. It's on the FS Projects incubation, F# community incubation site. They're heading very strongly to version 1.0. They're version 0.34 at the moment, with just a few items left to knock off the version 1.0. And great work by the team the community team who are now looking after this. Okay, so here are the docs. We have getting started, similar to here. You just install the fabulous templates, and then you do new fabulous app on some particular app, and then you land in a Visual Studio project like this. I've actually added a few things here. Hang on. Let me just sit down for this. And because I'm getting old, I have to put on my glasses these days. Okay. So I've launched this app, and here it is. It's slightly modified from the one you get. As you can see, it's a super flashy user interface application here. We'll talk about, I've said I haven't promised any flashiness, okay. So the important thing here is, let's take a look. Let's uncomment some of this. Let's comment out this here. And we'll comment out the smaller button here. Okay, just check my, yeah, there we are. So okay, I don't have on top, so I've got to do this. Here we are. Okay, so we're running Visor on the right to my Android phone here, my Samsung. And we're using the live update tooling that does come with Fabulous. You do have to, at the moment, it doesn't launch automatically. You have to launch a background process here. And that will enable live update in your application. So you see you get about 2-second turnaround time on updates to your app. And the code is being recompiled effectively, rechecked on your machine, and a web connection is open to the app running on the phone, which accepts a new chunk of code to use as the logic of your application. Okay, so we have our code here. So bigger here. So at the moment, we can keep making things bigger forever, but what if we want to put a limit on this? So we want to do that business of changing its can execute behavior depending on what the actual model is. And we'll save that and update. And now when we come to bigger, and we come there, the button is appropriately adjusted for its logic. No data binding needed there, just view re-evaluation. You can just forget all about everything you knew about data binding, more or less. Okay, we'll add a new option called a reset button as well. And let's just track through what the reset button does here. So there's a message type up above. I'll just skip forward to the very basic structure that you'll see in every MVU app. We have a model here. We have a set of messages, which can cause updates to the model. We have the initial state. We have the update function. That was the thing that comes back around to given the model and a message, produce a new model. And it's usually model with some updates to the model. You generate an actual new model. You can, if you really need to, use mutable state in the model. You can do that, and just actually change it. But in this, we're using the fully functional approach here. And here's the view function. It takes a model and a dispatch like you saw before. And it can be dynamic. The actual content that you render, in effect, can depend on the model state. So if model is pressed, do something. Otherwise, do something else. So this is compute the view. And that's it. That's an app. Okay, so what have we got here? We've got a reset button. And our visor here, we can go bigger, bigger, bigger. And we do a reset. And we'll just double check what happened there. We are in the update function. It produces the initial model here, and also you can produce what's called a command. That's the only other concept. It's basically just an action that happens, an asynchronous action that gets started as a result of the update, and can itself do send further messages back around the loop. Okay, so reset happened, and it returned the initial model of size 2. And we'll see where that got dispatched. It got dispatched in the command to the reset button, dispatch reset here. Okay, so let's start adding some new functionality. We're going to add a new game button, but new game hasn't been defined yet in our messages type. So we'll come back and we'll actually define all of these message types. And we'll define what happens in a new game. It just goes back to the initial model. And I think we, okay, I'll actually leave these ones since we're not using these yet. I'll comment those back out. And now we have a new game, which is more or less like the reset button. Because it's actually more or less the same, I will uncomment comment that out. Okay, so let's start adding some new messages here. We're going to, well, what will we do first? We will put a grid on here. And initially, we will make it only contain box views. And I will comment out this code here. And we'll need our helper function called makeGrid. So if you've got a part of your user interface which recurs commonly, you know, the object-oriented way of thinking about it is let's make a class which represents a new control, because it's going to have mutable state and so on, in order to capture that commonality. And that's why they start using implementation inheritance to start reusing fragments of components in user interfaces. But in this world, because everything's functional, if you need to make lots of grids in your applications, then you can just have a function which abstracts out the process of making a grid, because it's just taking data, the number of rows and columns, and a function to generate a view element for that grid, for that part of the grid. And you generate the grid, and then you just reuse that in lots of places. So your element of reuse becomes just normal functional programming. And that's absolutely key to why it's more productive, because you don't have to use implementation inheritance. So we have our nice blue grid. Now let's make it that we're going to put an image on the grid here. We'll take this. Now we'll need this thing called solution here. We'll start commenting these out. This is, make all of these, and I think that's okay. So we've changed these elements, if all going well, now contains different images for that, for the different locations. Okay, right. Not in. Okay. So let's now go to the next step, which is we'll initially hide all of those images. It's just, actually, I'm going to start, and I'll take the game over out. Okay, now we're going to have a message to reveal an image here. Should I just uncomment all of this? And hide. Okay. And we'll put the game over. Comment. And we will put in the logic that to get rid of this line, get rid of this line, and okay. So what's happening here? So if we've already revealed an image, then we will show the image. So that's a dynamic part of the UI. And if it's not revealed, we're going to use a grey image And we're going to have a tap gesture recognizer for when we tap on the image here. And then the image will be revealed. And you'll see those coming through like this. Okay, and then at each section, as I was tapping, what was happening, we can just trace through the flow of the logic. It was sending a message called reveal around the loop, which is here. It's just it's just data, nothing complex in that message, revealing a position. And we'll see where it gets processed. If I've already made a first choice, if I haven't made a first choice, then we would just reveal the image. And if I have made a first choice, well, we do some slightly more complex update, including that game over logic to say it took me 37 seconds. And now, because the user interface is dynamic, then the business of how big that grid is as the user becomes better and wants to play a bigger game was handled purely through the make grid function, which is just passing that model.count in and just generating a bigger grid, and then the updates happen, and it becomes smaller and it comes back. And that can be the sort of thing which in Zamel, the move from doing a static UI to doing a dynamic UI is actually a big change, right? Because the static UI, you've hardwired your 3x3 or 2x2 grid and so on. And then to suddenly make that dynamic, it's just like, oh my God, what do I do? Well, in this setting, it's dead simple. You just program it and generate the different UI. And it's just this, instead of being, 4 and 4 here, in which case, if I'm, actually, that might, okay, no, that was right. I gotta check that. Anyway, you get the idea. It's easy to make the UI static and make the UI dynamic. Okay, so that's your sort of hello world of your dynamic UI fabulous application. Looks a lot like a Fable Elmish app and a lot like an LMAP. Okay, it's all functional programming. UI becomes information flow. View and model, update, adjust functional programming. Views are recomputed. The new view is applied, crucially for performance, applied to the underlying controls using differential update. And if the view actually hasn't changed, then no updates are made. And messages are explicit, and it's very easy to get a full message trace and to debug with respect to what are the actual messages coming through your application. Okay, so, right, that's not pretty. So how do we make it pretty? First of all, this Xamarin Forms supports CSS styling. These slides are taken from Mark Mallerbone's talk. I'd strongly recommend you look at his material on using CSS styling with this kind of work. I am just going to play a short video of Mark's one of the front ends he's made using Fabulous. And I haven't listened to his narrative, but my understanding of this is it was a comparative project versus coded UI, and this using Fabulous or using Zamel, and this is the results of the coded UI. But just to give you some sense of the dynamic kind of feel you can kind of get with your application. Okay. Okay. Here are some other apps that are being written, just to give you the sort of feel that what people are writing here. I'll talk more about this app on the left. This one on the right uses these 3D displays called Ohoo, a 3D display component called Ohoo. You have maps integration, you have charting integration, and so lots of good eye candy there. Elmish Contacts is the one that was on the middle left, and it's an absolutely wonderful, I almost said absolutely fabulous, but it's absolutely wonderful application for learning. It's got lots, if you're doing an information-rich application, on-device SQLite integration, uses maps, async data loading, and all of it just following the same kinds of architecture and sending messages around, and all of it within the paradigm. Using all these Xamarin Essentials things, sending SMS, phone calls. It's a multi-page app, which is there's an important technique I'm not covering today, but using these external messages to reconcile the different components, and etc. etc. So that's all open source, and you can help improve that as a sample application. and actually use it yourself as your contacts app on your phone if you like. So just to say that, what is that view DSL that we were using to describe views? It is actually very similar to Zamel in many ways. You can actually do a one-to-one translation between Zamel and your view DSL. You can start looking with Zamel that looks like this, and you get a view that looks like this. So you can see how the structures and names are all being carried across. So it's complete. So the view DSL is everything that's available in Zamel is available in that view DSL, but we strip out some of the things like templating and the like because they're not needed. If you're interested in like, well, how do you handle really enormous lists of data, that is covered on the fabulous website. There's topics on that. Okay. Right. Okay, so you may be interested in animations. Like in React, obviously there's similarity with some of this with React. We use refs, and so you declare these things called view refs, and then once you have a view ref, you can trigger off these asynchronous animations and either tie them into the messaging model if necessary, their completion and the like, or you can just ignore the results and just say, okay, the animation on that element is going to run for as long as it runs, unless that element actually gets annihilated just because of some later view update. And then, so we have a ref here where you name it. I'll point to it here, ref, animated label ref, and then you dispatch the poke message, and the poke message checks that we've got something to animate, and then it triggers off the animation. Okay, multi-page apps, yes you can. You still ultimately have a single view function, but it usually returns one of these structured things, which is like a carousel page. So a single view function is specifying all the possible pages of your app, or in the navigation, it specifies the whole stack of things. So you've still got this thing. You've got a state of your overall app, and you've got projection to multiple logical pages. And each page has its own model, message, and update function, and then you compose the pieces just using normal F# code. And there are good examples of that, as I said. So how do we make this efficient? Well, first of all, crucially, the view application to the actual view controls is done differentially and incremental update. But if you've got something like this, and it can be very helpful to make sure this part of the view only gets recomputed if necessary. And you can do that by using this depends on function, and you list out the things that it depends on in here. So it might depend on the model count and the model step, and they become available internally as the count and the step. And this model actually has a different type now. It's like do not use me type. Okay, so you can't actually use the model internally in here anymore, but you can use the count and the step. So we use the count here. And this means that if the count and the step were the same as the last time, even if some other parts of the model have changed, if the count and the step were the same as the last time, we actually don't do anything. Okay. We don't do any updates to the view. We just return exactly the same view description as the previous time. Just running through some pragmatics. You can persist state. It's very simple in this setting. You just persist the model, usually serializing it to JSON. You can do it manually as well. We don't do this time travel debugging. It's actually very, very simple to implement within your own app. Like, just go back in time, please, through the app. And that's used just app.set model and just to a previous model. If your model is purely functional and doesn't contain any mutable state. If you're interested in what your app size is, you just use a standard Xamarin linking and reduction to get nice small apps. The core logic of your app is .NET Standard 2.0. Each platform you want to run on, something I haven't mentioned, by the way, you can do GTK, you can do UWP, you can actually do F# UWP apps realistically for the first time using this framework. And you can deploy them to the App Store. It's not a fully supported scenario by Microsoft. There's some caveats with that, but they are saying, yes, you can do it. It's on your own app, but you do it. And you can do WPF apps, and you can do Windows Forms apps as well. Okay. You can pass in platform helpers if there are differences. You can use platform conditionals and so on. And App Store deployment just follows normal Xamarin processes. Just use everything that's normal in the docs. there's lots and lots of other Xamarin functionality, Xamarin Forms functionality developing around there. This new thing called Shell is great. Visual Material is another one. They're all available on NuGet. A thing like Xamarin Essentials is, like it says, absolutely essential to get good work done in app development, and it's nearly all orthogonal to the questions of the view elements. It's just things like sending an SMS that is just works just like it should. So you might say, can I define my own view elements? Okay, say for maps and the like. And yes, there is an extensibility story. It's documented on the website. You have to write a short amount of code to make that, I'll just bring it up for those interested here. Let's take a look at views, extensions here. And there's a guide here for writing a view extension. It will be about that much code for a typical view extension. And for example, the maps extension is described here. Okay. And there are standard NuGets for maps, for 2D graphics and animations, and for charting with Oxyplot, and for 3D graphics with Ohoo. Okay, so that's most of what I wanted to cover. If you're actually new to F#, this is a fantastic book to get started with, Get Programming with F# by Isaac Abraham. Read that first. It doesn't cover anything about Fabulous, and then move over and get started with the Fabulous. Actually, you don't even really have to read this first. You can probably just dive into F# with this Fabulous programming plus one of the others, plus the first few chapters of a book like this. Okay, thank you very much. That's Fabulous. Fabulous is a simple F# MVU app programming. And as I said, please contribute and get involved. Thank you very much. So, have the other talks been taking questions? No. Yeah, anybody got a question? Yeah, here. I'll repeat it once it comes through. Yes, that's correct. And there are important reasons for that. So let's go back and look at an example of that. So the question is, in this style of DSL that we've used, oh, sorry, can you put me back on? Let's see, I'll just make sure that I can point here. Yes, we're using optional arguments here. So each of these view elements actually have a very large number of optional arguments available. Whereas in Fabulous, it uses sort of attributes like in HTML. We did this for a few reasons. One is to get very strong naming on the on the arguments. The other thing is there's an important F# compiler optimization that applies, which it takes each of these view descriptions and all the optional arguments, and it actually inlines it one step, and there are actually like 200 different possible optional arguments, and it reduces those down because it knows you only specified 3. And it can see that you specified 3 attributes, so it can pre-allocate an attribute property bag, which contains exactly the right number of attributes, and just fill them in very efficiently. So it makes the view element creation highly efficient. So there's a set of things that kind of happen to come together to lead to this choice. It's also quite a nice ergonomic API, but I don't mind the way they did that in Elmish. It's just this also got us some performance goals. Next question, please. Is there another? Yeah.
So in your demo project, you had Android and iOS targets.
Yeah. The UI code is the same.
Yeah, so then the question is, could I add like WinForms?
Yeah, so I should, by default, we only create the Android and iOS because the others were a bit fresh. But if you actually want to know the full set of platforms, then that's there. So you can add WPF, UWP, macOS, and GTK. and you get Android and iOS. So you get all of that, it's the same application code, same view code. Okay. Yeah.
How would you say this compares to using React Native with Elvish? Is it a simple tooling story or?
I actually I did once try to get the get started path on React Native and Elmish, and I can't do a like for like comparison. Stefan Forkman is a good person to ask. He's doing React Native. With Elmish, I mean, I think he tells me this looks pretty good in comparison. So yes, you can do Elmish and React Native, and I'm very glad that we have both, because one's JavaScript based, one's .NET based. Oh, well, yeah. So I can't really say this. I think this has got a lot of technical advantages, but I'd just be guessing. So, yeah. One more question, maybe? Yeah.
Is there a separate compiler involved, or is it just the standard F# compiler?
It's the standard F# compiler, and the Xamarin. Yep. This is just you running using Visual Studio on Windows. You can do it in Visual Studio on Mac. Yep. Totally standard. Cool. All right. Thanks very much for coming, everyone, and we can talk more afterwards. Thanks.